Here we are, lesson 7-2, rational exponents. So the target for you in this lesson is to learn how to take fraction exponents, turn them into radical form, which will allow you to simplify a number or an expression. So yes, our friends, the fractions, they are returning for you. Yes, along with not only that, but fractions as exponents. So here we go. Let's make a review though, first of all, of an exponent power rule, and that's going to help us as we work through our examples. First of all, when I have 5 squared raised to the third power, that is going to then equal 5 to the 2 times 3. We will multiply these two exponents out here, 2 times 3, 5 to the 6th power. You're going to be using this rule where we're multiplying the exponents here to help us get rid of your friends, the fractions. So here we go. Let's take a look here. We're going to have all of our rational exponents in the form of a 1 over n. So in other words, we'll have a 1 on the top of the fraction and an n on the bottom of the fraction. Let's take a look first of all at this. Here's one, 5 to the 1/3 power. And we're gonna figure out what does this mean. So how we can fill in the question mark. So I have some things to show you here. All right, so as we work with this now, let's say we have 5 to the 1/3 power. So we have some number equals 5 to the 1/3 power. So we don't like these fractions, do we? So how do we get rid of those fractions? Well, in order to get rid of this fraction here, I can actually use this power rule up here, the multiplying of the exponents, and I can actually change this equation. What I will do then is I'm going to take and I will cube both sides, and I will say that n cubed will equal 5 to the 1/3 power cubed. And now I will use the rule up here that we reviewed, and I'm going to multiply these two exponents over here. So then I have 1/3 times 3. I'm going to do 1/3 times 3. Well, if I do that, I do the numerator times the 3, and 3 times, which actually has a 1 sitting here, I get an answer of 1. I get a nice exponent. So now I say that the number cubed equals 5. Well, that's kind of cool. That makes it maybe hopefully a little easier. So then just what does that mean? Well, if I want to find the answer to n cubed equals 5, let's go back to something else you've done already. Well, let's say I have n squared. Remember when you had an answer in the working with the Pythagorean theorem, you had something that said maybe it said b squared or a squared? Well, let's say n squared equals 16. How did you find the answer for something like this that I'm writing over here in green? Well, you would do the square root. The square root of n squared equals the square root of 16. And this n would equal 4. So now, applying this idea, since I did the square root of n squared, I'm not going to do the square root of n cubed. What am I actually looking for here? I am looking for the cubed root. I will now cube root each side. So I do a little 3, and then I put my radical symbol, and on the inside I put n cubed, and then that equals, I will say, the cubed root of 5. So now when I do this, I can say that n equals the cubed root of 5. So now what I've done is I have actually taken my fraction exponent, 5 to the 1/3, and now I've changed it. So let's take a look at how they're related. We're going to look at this line right here, that n equals 5 to the 1/3 power, and n also equals the cubed root of 5. Notice both of these, 5 to the 1/3 power equals n, and the cubed root of 5 also equals n. Since both numbers right here and down here, since these equal the same thing, here's what it means, then they are also equal to one another. So what am I saying? I'm saying that since n equals 5 to the 1/3 power and n equals the cubed root of 5, that means that 5, since n is equal to two different things, that also means these two things, 5 to the 1/3 power is the same as the cubed root of 5. So essentially what the fraction exponent is telling you when you've got a 1 on top, it's telling you, and the denominator is telling you what root to find. So if I have 5 to the 1/3, that means find the cubed root of 5. That's what all of that means. So let's take a look at some other examples together. Why don't you, might be a good idea for you to write some of these down as you go. All right, if I have 4 to the 1/2 power, so what does it mean? It means I am going to find, well, and if there's a 2 there, that means find the square root of 4. Now, what is the square root of 4? The square root of 4 is 2, so I'll simplify that to 2. 4 to the 1/2 power means find the square root of 4, which means the answer is 2. The next example is 64 to the 1/3 power. What does that mean? Okay, that means I'm looking at the denominator. I have a 3 down there, so I will say I'm looking for the cubed root of 64. So what number times itself 3 times equals 64? You do that on your calculator. If you don't know how to do that in calculator, you're going to think ahead. Let's see, what can I do? Well, the answer to that happens to be 4. Okay, so now some calculators do have a cubed root function like this. Others have a function that looks like this. So x and then a square root symbol might look like that. And I've seen some that have a y with a square root symbol with an x underneath. Okay, and then I have seen, and then these are the two most common that you'll see on your calculator to do that. What you would have to do to type this in, the cubed root of 64, it depends upon the calculator. So if you bring your calculator to me, I will show you how to use that function on your calculator. If you want to experiment with it, experiment with it. Most of them would start by typing in the 64 first, and then you would type in this symbol here, and then you'd tell it what root you want. Some do it the other way around. Some say you got to type in the root first, and then you got to type in the number. So if you're not sure, play around with it on your calculator. If you need help, bring it to me, and I have worked with many different calculators. I can help you figure out how to do your calculator. Moving on, now we have a variable, x to the 1/4 power. Well, then that is the same as the 4th root of x. That's all it is. And I can't simplify this any further. All right, otherwise I don't know what x is, so I don't know what that number I'm after, so I would just leave it like this. X to the 1/4 is the same as the 4th root of x. Moving on, negative 25 to the 1/2 power. One thing you have to look at here, there are no parentheses here. So we need to look at this number this way, that means negative 1 times 25 to the 1/2. The 1/2 does not go to the negative symbol. There are no parentheses. So we have to view this as negative 1 times 25 to the 1/2. So what does that mean for us? It means then that is the negative times the square root of 25. Because negative 1 can be just written as a negative sign. And the square root of 25 is 5. So the answer to this is negative 5. So again, negative not inside parentheses. That has to be viewed as negative 1 times 25 to the 1/2 power, which then equals the negative square root of 25, which equals negative 5. Another example for us. In this time, notice I have parentheses, and on the inside of the parentheses there is a negative sign. So following what we've done before, I have a 3 as a denominator. That means I want the cubed root of negative 27 y to the 6th. Cubed root of negative 27 y to the 6th. So what can I do with this? That means mentally now what I have to do is mentally kind of break this up right in here. I'm going to do the cubed root first of the negative 27, and the cubed root of negative 27 is negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Then the cubed root of y to the 6th. What number times itself gives us the cubed root of y to the 6th? All right, so now when you look at this, you got a 3 out here. A little shortcut for you. To figure out this very quickly, take the exponent of 6. What is 6 divided by 3? 6 divided by 3, of course, is 2. So a shortcut to that is, an algebraic pattern is, if I take the 6 and divide it by the root that I'm after, it tells me the exponent in my answer. Because if I do y squared times y squared times y squared, I will get y to the 6th. And I add those three together, that's going to equal y to the 6th. So what is the cubed root of y to the 6th? Y squared. So on this one I then have an answer of negative 3y squared. All right, we're reaching 10 minutes. I'll wrap this up with two more examples for you. If I have 7 times x to the 1/5, this 1/5 only goes with the x. The 7 is separate from that. There is no parentheses there, so this exponent only goes with my variable. How do I write this one? I write the 7 all by itself. Now I need to put a radical sign. I need to put the 5 out here to say I'm after the 5th root, and my x goes underneath. So this is 7 times the 5th root of x. That's what this is saying. And the last example to show you, 1/36 to the 1/2 power. That means I need to take the square root of 1/36. The square root of 1/36. Well, we're getting a little ahead of ourselves here, but just to show you, when I do this, notice 1 and 36 are both perfect squares. Actually, what a calculator will do is they'll say, what's the square root of 1? 1. What's the square root of 36? The calculator say 6. So the square root of 1/36 is 1/6. And just to multiply that out for us real quickly, is 1/6 times 1/6 equal to 1/36. 1 times 1, 1. 6 times 6, 36. All right, hope you took the time to write the examples down. If any time while you're working, come back and look through these. These will help you with what you need to do. Brief assignment for you here from page 426 and 427. I want you to do just numbers 1 through 16. All of the problems there, 1 through 16, will be something like what you've seen in the video here. So page 426, 427, numbers 1 through 16. Go ahead and get started on it. Be sure that if you need to check the answers to the even number problems, please check my textbook. Good luck. Let me know what I can help you with.